Hi everyone, and without any further introduction, I think I'll just give the floor to you. So Leo, please start.
Thank you, Alexei. So, hello everybody. My name is Leonard Püttmann, and I'm really excited to be here today and talk about how you can take retrieval augmented generation to the next level. And for that, I will first start off with a small slide deck for which I will share my screen with you all. I'm using Zoom, so little where can I share my screen? Give me just a second. Okay. All right, you should now be able to see my screen,
Yes.
right? All right. If anything comes up, technically, just feel free to interrupt me. Otherwise, I will just start.
I already see some questions, and then for everyone who is watching this, feel free to drop your questions in the live chat, and we will see if question is relevant to what we're talking right now. I will ask immediately, especially during the demo. But if it's not related, we will keep it to the end.
Yeah, sounds good. I'm going to do like a theoretical part for about 15, maybe 20 minutes now, and maybe afterwards we can already talk about some questions. And during the hands-on part, then of course we can keep it more dynamically and do it more freestyle. Right. So, but today we're going to talk about how you can unlock next level retrieval augmented generation. And the aims of the session today are that we are, first of all, recapping a little bit, okay, what is retrieval augmented generation and why do we even need a next level RAG approach? And why do we need something that we call data-centric retrieval augmented generation? And what are the, let's say, common pitfalls that arise during these RAG projects? We're also going to have a hands-on session where we're going to use our open source tools from Kern AI to build a really cool RAG project. And of course, the goal for this workshop is also to give you some really valuable tips and tricks for your next RAG project. Hopefully, by using the Kern AI tools, but if not, then also for other RAG projects as well. So some general RAG ideas. Before we start, allow me to introduce myself shortly. My name is Leonard Püttmann, and I'm a solution architect for data science and machine learning. I studied in the wonderful town called Düsseldorf in West Germany, and I've been working at Kern AI since May of 2022. Me personally, but also Kern AI as a company, we have been interested in natural language processing for quite a while. So even before RAG and the advent of ChatGPT came up. And we have also been always focused on a very data-centric approach. We think that models are often rarely the bottleneck, but instead we try to push the thought of taking a look at the data that you have at hand and improving the quality of your data. And this also, of course, applies to retrieval augmented generation. So let's get started with the topic itself. Let's maybe talk a little bit about the wordings and terminology of RAG a little bit before we take a look at some common pitfalls and things that can go wrong in these RAG projects. And the idea of RAG itself is actually quite simple. What you have is you take a large language model and you connect it with some data that you have, maybe some internal data from your company. And you can then use the data that you have to answer quite complex questions very quickly. The thing about language models like ChatGPT and Llama 2, of course, is that they have quite a lot of internal knowledge, but they also tend to hallucinate quite often. And also they haven't really seen a lot of the internal knowledge that is hidden in many organizations. And so when you actually connect these language models with sort of like a mini search engine of your data. You can use them for very specific tasks, and you can do so very, very efficiently. So the general idea of RAG, actually not too complicated, I would say. And why should you care about this at all, even? If you can manage to combine the power of a language model with the hidden knowledge that is inside the data of your organization, you can have a huge operational leverage. Think about labor skills, or like the shortage of labor skills. Many companies struggle to find good people, and have too many requests from customers and too few people to take care of all these. And if you maybe give such a RAG tool into the hands of your employees, you can drastically increase the efficiency and the speed of how your employees can access the data in your company. And that means that you can much more quickly and much more efficiently answer the questions of your customers, for example, which in turn increases the customer retention. So I'm probably not the first one to tell you this, but generative AI yields quite a lot of opportunities to tackle very big problems that enterprises face today. And we can use RAG today to solve these problems. We don't need to wait for a GPT-5 or a Gemini 2.0 or something to tackle these challenges, but we can use a RAG approach today. And I'm also quite confident that RAG is still here to stay, because even if these models are getting better and better, that doesn't mean that the data quality that we use and need for all these use cases is going to improve. And the next level and data-centric RAG approach is a fantastic way to deal with all of this. And maybe you have already prototyped a little bit with some RAG libraries yourself. There are quite some popular libraries out there, or some enterprise tools even. And maybe you've quite quickly realized that getting started with RAG is super simple. And if you only have one document or just a couple of documents, it's not too difficult to process them and transform them and push them maybe into a vector database and do some similarity search and enrich the context of a language model with your own data. And that's actually not too difficult if you have small amounts of data. But if you have vast amounts of documents, if you have quite a lot of data, things can get really, really difficult really, really quickly. And that's what we at Current AI also feel on a daily basis, is that with enterprise projects, and if you have really large amounts of data, RAG can be super, super difficult. And using a data-centric approach is basically the only way to move forward here. And the issue that we often see in these RAG projects is that people don't really think about modeling their data. They don't really think about the shape and the structure and the size of their data, the transformation techniques that they maybe need to apply. And so when they then retrieve some context from, say, a vector database, what they retrieve is not really the right pieces of information. And so when you retrieve data that's not useful and feed this into a language model, the answer is unhelpful or maybe even plain wrong. And also the language model has no real understanding of what the answer should look like. And so it's still very confident in its answer. Or maybe it's just saying, so sorry, but I don't have any information about it, which is also very unhelpful.
And one comment before you continue. So we see
sure.
this blue patch on the right, and I think this is what Zoom is doing, because you have like something there. Like if you move it so it doesn't interfere with the slide.
It should be better now, right?
Yeah.
I moved it.
Yeah. Thanks.
Okay, cool. Thanks for the mentioning. And so a problem what we often see is that people think of AI as this magical black box where you just push in a question and then some magical thing happens and you get an answer, you get a response that is great all the time. But that's obviously not the case. And people really struggle to have systematic thinking when it comes to these RAG projects. Because in reality, you, of course, start with some sort of question usually, but you also need then some form of content moderation, for example, or you need to enrich the question. How does my question look like? What topic is the question actually interested in? Is it a complicated or a uncomplicated question? You need to then go about and retrieve data. Maybe you need to filter out some of the retrieved data points then again, and then generate, of course, an answer, maybe post-process the answer to make sure that it's in a specific format. And you have all these components that really make up a RAG system, if you really think about it. And especially when it comes to search, we see search more of a multi-step function rather than a thing that's just one component most of the time. In many very basic RAG projects, you just go about and create a vector database. You embed all the text data that you have and push it into that vector database and then do something that you call similarity search. And that's good for some cases, and it helps you retrieve some data that is somehow related and similar to that question, but it does not guarantee that the data that you retrieve is actually useful for answering a question. So what you can do is you can, before you do any data retrieval, you can do some intent recognition. First of all, try to find out, okay, what topic is the question interested in? Kind of narrow down the search area before you even start searching. You can add a graph-based retrieval approach where you also retrieve other relevant references that are somehow connected to a data point that you retrieve. And you can also use something that you call a cross-encoder, where you use a sometimes very lightweight model to filter out unrelevant results that you fetched from the vector database, which can really help you keep the context length of your language model small and not make it too big. And also it can help you get a more accurate and relevant response from your language model. The topic, as you can see, is quite complex, and I could probably just fill the next hour or hour and a half of just talking about this data-centric RAG approach. I would say maybe now is the time to shortly jump into the tools that we are going to use today and get our hands really dirty. But if you would like to learn more about this and the fundamentals of data-centric RAG, then make sure to subscribe to our newsletter, because we're going to release a really cool guide on exactly this topic really, really soon. And with that, that's already the theoretical part. Yes, sure.
How do we subscribe to the newsletter?
Oh, that's a good question. I also have a QR code at the end of the session, but you can also subscribe if you go to current.ai/resources/newsletter if you would like to subscribe.
But you'll show this slide again, right?
Mm-hmm.
So then we shouldn't worry about this right now. Okay.
Yes, exactly. All right. Alexei, maybe we can now answer some questions, and then I would say we can dive into the open source tools if you'd like.
So there is a question if it requires a GPU, but I think it's more about the tool, right? Like we will use Refinery, right?
Yes. Yes, we will use Refinery. It does not require you to have a GPU. If you do have a GPU, that's of course very nice. Or if you have a powerful computer in general, that's always good, because then you can use bigger and more powerful models. But we will also take a look at some models and techniques that don't require you to have a very beefy machine or a GPU even.
And the other question is maybe more practical, like if we can have access to the presentation.
If you'd like to have access to the presentation, I can send it out after the session.
Yeah, we will include this in the description.
Yes, exactly. Perfect.
Yeah, let's continue.
All right, sure. So first of all, let me tell you a little bit about the tools that we are going to use today. The main tool that we are going to use, and the main tool that we started out at Kern AI as well, is the Refinery. We started out with the Refinery already in 2021, and Refinery is our data management tool and our API for fine-tuning models, for managing your data, and also for retrieval augmented generation. And Refinery is completely open source under the Apache 2.0 license. And another tool that we're also going to work with a little bit here, which we have released at the end of 2022, is called Bricks, which is an open source library for modular natural language processing components. And Refinery and Bricks really work well hand in hand together. And you can use both fantastically for transforming your data and for enriching your data, for example. Last year in 2023, we have released our platform Cognition, which is kind of like an orchestrator for next level retrieval augmented generation. And I will also shortly show you Cognition to give you the intuition of why you would want to have such a tool. But for the rest of the workshop today, we're going to focus on Refinery and also a little bit on Bricks. So yeah, again, if you would like to install Refinery, you can go to github.com/code-kern-ai/refinery and download the Refinery there.
Yeah, I also put the link in the description. So
Yes.
under the video, you should see the section with links, and then the link to Refinery is there. And I also posted it in the live chat like 10 minutes ago.
Perfect. Yes, exactly.
I'll
And
just post it one more time.
Exactly. And of course, if you are stopping by on our GitHub page, then feel free to give us a star, which is always very, very much appreciated. And you can either download Refinery by simply cloning the Git repository, which you can do here. It's also outlined right here. Or if you have Python installed or pip installed, then you can just simply do a pip install kern-refinery, which will then also automatically install the Refinery for you.
Mm-hmm. And you mentioned that it requires Docker, right? Because there is a question. Trying to get Refinery start, I guess it requires a Docker installation, right?
Yes, so you require Docker Desktop to get Refinery up and running because it's a Dockerized application. And so without Docker, you can't really use the open source version of the tool.
And you mean by Docker Desktop, you just mean Docker or specifically Docker Desktop? Let's say if I'm running this on Linux, where I cannot have Docker Desktop.
It should also work on Linux environments. To be honest, I haven't tested out with anything else but Docker Desktop, but yeah, I'm running it. To be honest, I'm running it here on Debian, which I'm using via WSL, so the Windows subsystem.
Then it should work anywhere.
Yes. So what you can do is simply git clone and then the repository, or simply do a pip install kern-refinery. And then if you would like to start the Refinery on Mac and on Linux, you can simply trigger the start script, which will take care of everything for you. Or if you're on Windows, you can simply execute the start.bat file, which will basically do the same for you, but just on Windows.
And then there is a question if you can run it in Google Colab. I guess the answer is no, you cannot, right?
No, at the moment, no, you cannot run it on a Google Colab. No, that's not possible.
I would suggest trying GitHub Spaces, Code Spaces. So if you want to have like a remote machine, a
Mm.
Linux machine where you can execute things without paying for them, like Colab, then you can try GitHub Codespaces.
Yes, there code spaces would also be a good alternative. Other than that, if you worry about Refinery using a lot of your hardware, or if you think that you definitely need a GPU to run Refinery, then you don't need to worry. It's actually quite lightweight, at least from a computational perspective. So we're not going to load any 7 billion parameter llama model into Refinery today.
Mhm.
But we're
And
going to
people
use like
install it with pip by running pip install kernel refinery. How do you run it? Do you also, because like if you install it with pip, you cannot really run this dot/start, right?
Um, so if you install it with pip, you should be able to start it with refinery start. So yeah, you don't really start it then with the /start command, but just type in refinery start. For this, then of course you also need Docker desktop then, but then you should be able to start it too.
So for refinery start, you need Docker desktop, but for /start, for this,
For both, so for
for the both.
both cases, but refinery start is the starting mechanism for the pip install command. But if you clone it from the repository, you can just do /start.
Got it. Thank you.
Okay, cool. Are there any other questions about
I
installing
don't.
and running?
So somebody says that I can install it in Colab, but then you will not be able to run it, I guess.
Yeah,
Like one
maybe.
running
I
pip
actually,
install there, but like running there.
maybe it does work. I actually haven't tried it out. I don't think it should work, but if you can get it up and running, then yeah, maybe.
Like I doubt they have Docker, but if they do, then it's good, right?
Yeah, that's true. Maybe you can hack your way into Colab and somehow install Docker. I don't know, not too sure. But again, it shouldn't be too hardware demanding for you. Okay, cool. Otherwise, you can find like very detailed installing instructions and also documentation and tutorials on our GitHub page. And I think you can always, of course, also join our Discord server if you have questions or troubles, where we also then can help you get up and running with Refinery, of course.
Yeah, there was a question, how can we reach to you for further questions? And I guess Discord would be the right place, right?
Yes, here's already a Discord link where you can join our community, and also you can follow and contact us on LinkedIn and Twitter.
The
Yes, that's
newsletter
probably
that
the
you
best
mentioned,
way.
I guess this is the second link, right? Like after Discord, you have the newsletter link.
Yes, here's our newsletter as well, but I think it's outdated. But yeah, just joining the Discord is probably the best
Oh,
option.
maybe you'll fix the link after this call.
Yes, definitely. Okay. Cool. Then I would suggest that we slowly start jumping into our tool Refinery. When you open Refinery, you should
Can
be,
you enlarge it a little bit? It's like tiny,
of course, here.
maybe a bit
Is
more.
that better or even larger, maybe?
Yeah, that's better. Like for
Okay.
you, if it's convenient for you, for me, like I have a small screen, and for
Mhm.
you, it's also.
Oh, that's totally fine for me as well. If you open up Refinery for the first time, you should probably not see a project like I have here right now, but only the 4 buttons where you can create a new project or import a previously created project. Or if you would like to follow along for this demo today, you can also choose one of the really cool demo projects or sample projects that we have right here. I would especially recommend to use the conversational AI project, which is basically about detecting the intent with conversational lines. And it's also really nicely applicable to a RAG use case. For the workshop today, I'm going to use, however, a slightly different data set, which is a little bit closer to what you would usually want to use in a RAG project. because we at Kern AI, we have created our own imaginary insurance company, which is called Global Guard. And our imaginary company, Global Guard, offers some really cool insurance policies on traveling and health insurances. So something you would really typically use in a real world RAG project, so that your customers can write a message such as, hey, I suddenly got ill and I can't take my flight or I can't take my vacation. Is that actually covered by my policy? Or maybe you broke your foot during a trip in Rome and you want to find out if your hospital bill is insured, things like that. And so,
You use ChatGPT to generate this?
yeah, a little bit of it, at least. Some of it is humanly generated, but some of it is also ChatGPT generated. Yes. And yeah, that's the data set that I'm going to use for the project today. So I'm going to create a new project here and call it demo. Oops. For the live session. And then at the moment, you can only create a new project via a CSV or a JSON file or even an Excel file will do. But in the future, of course, you can also query the API or integrate via a database. By default, you can choose between English and German. If you need access to a different tokenizer, then feel free to reach out and then we can help you implement that as well. But for our project today, the English tokenizer will do just fine. And then I'm going to upload the spreadsheet that I have prepared. So basically what we did is we converted all the texts from the PDF documents into smaller chunks, basically one chunk per paragraph is what we did. And we saved that into a Excel spreadsheet.
Did you do this manually, or there is a special program tool script that you can use for that?
So you can just write a very simple Python script for that to extract the text. I think that's what we did in this case. On our platform, we also offer like a service to extract data from PDFs, or a tool that we really like to use. Maybe that's also really handy for many people, is called PDF to Markdown. And that way, maybe I can show this live with a PDF file. You can just drop in PDF files and then convert them into a Markdown file. Not working well right now. Maybe try again. But yeah, that way you can very easily extract text from PDF files as well, and then put this into a Excel file, which you can then.
Can you also show us this spreadsheet so we have some ideas how it might?
Yeah, sure. The spreadsheet is right here. So don't be afraid from this massive wall of text. Basically, what we have here is just two columns. One column for the name of the original PDF document. So for example, the Global Guard health.pdf. And then we have a column called content, which contains basically all the paragraphs in that.
Yeah. So what you did is you converted the PDF into a Markdown file, and then there is another script that takes the Markdown file and turns it into a spreadsheet, right?
Yes, we used some Python regex to then chunk it up into smaller bits and then have it
have it somewhere.
Don't have it at hand at the moment, but maybe I can share it afterwards.
The gist, and then yeah, share it afterwards. I think many people will find it handy.
Yeah, sure, of course. Okay. Now we can take this spreadsheet and upload it to Refinery, which is very easy. So click on Proceed here. And now, first of all, the tokenization from the Refinery project will be triggered. It shouldn't take too long. I mean, we only have 109 data points, so not too much. So it should be done relatively quickly.
And we already have two questions. So the first question is can we use multilingual? Like if we have a file with multiple languages, can we use it?
Yes, so you can basically use any language that you like. So Refinery will not stop you to upload it. You just need to keep in mind that in the background, we use a tokenizer for all these texts from a very popular NLP library called Spacey. And Spacey has some really handy features like allowing you to further split or tokenize or process your data. And if you have very multilingual project, but you set the tokenizer, for example, to English or German, it's not guaranteed that it will work really, really well. But as far as I know, there's also a multilingual tokenizer from Spacey.
This is per file, right? So we don't set the language per entire project. We set it per file. When we upload a file, we say this file is in English, and then we can upload the other file, another file, which would be German, right?
Yeah. So the language settings are per project. What you can do is, of course, take another Excel spreadsheet, for example, and also upload it here so that you maybe have more data. But the project itself always uses one tokenizer, and that can be a German or an English tokenizer or a multilingual tokenizer.
Yep. Okay.
Yes, exactly. Okay. And the first thing that you would like to do when you create and upload a new project is, of course, check the data that you have. First of all, to make sure that everything went well, oops, got signed out here, that the data is looking well, that there are no issues with the data. And also you would want to get a first feel of how the data looks like and maybe the structure of the data. And here we can see that usually the paragraphs, they are not too long. Sometimes they're actually quite short. But if we scroll down a bit, we can see that they are getting a bit longer. And these long paragraphs, they could also already cause some issues. For example, when we put this into an embedding model like this, the similarity search could be a little bit inaccurate, or we could have difficulty finding very, very long paragraphs in our texts. So we need some form of approach to tackle this. And for that, we can go back to the settings page and click on this new add new attribute button over here. With the attribute button, or with the attribute calculation button, we can programmatically change the data that we have and create new attributes by using relatively simple Python. And what I can, for example, do here is simply split up the data that I have. Maybe let's call this function content sense so that it is more clear of what we want to do here. I can split up the original paragraphs into individual sentences. Now I get an error here. Maybe I can run it again. No, maybe let me delete this and try again. Start from scratch. So what we want to do is we want to take the content attribute and split it into individual sentences. Yes, perfect. That worked well. So what we did here is, maybe I can show it in this with this data point. We have a very long paragraph here, and we want to split it into smaller chunks, in this case into individual sentences. What we can then do is we can embed these smaller sentences so that the similarity search is a little bit more accurate and that it's more easier for the vector database to actually retrieve relevant facts. But maybe
that's why
we
need the tokenizer, right? Because tokenizer can also, it's not just word level, but also sentence level, right? So the tokenizer can send, here's one sentence, here's another sentence. Okay.
Exactly, because the content itself is also available as a spacey doc. That's the name of the object, and we can call this spacey document from the tokenizer by taking the record here. And if we just take the .sense, we can extract all the individual sentences that were extracted by the spacey tokenizer, which is really, really handy if you have longer paragraphs that you want to then chop into smaller bits and pieces. And if you just want to try out the code that you've written, I mean, this is not very complicated, but sometimes you have more complex and difficult transformations, you can always use the Run on 10 button here to just apply this transformation on 10 samples without persisting them, just to get a feel for the code and get a feel for the result. And here we can see that actually worked quite well. So all the paragraphs were chunked into smaller individual sentences. And if we are happy with this, we can just click on the Run and Execute button. And this just, in a couple of seconds, creates a completely new attribute that we can then use. We can also unhide it and then check it again in the data browser. And here we can see that we have now created a completely new attribute based on the original content attribute. All right. Another technique that's also really, really useful and that we at Kern AI often deploy in our projects is to chunk the paragraphs even further and to extract very specific information, such as, for example, only the nouns of a text. And we can do exactly the same as we did before. So we can create a new attribute called content nouns. Make sure to make it the attribute type embedding list. And here's where our second open source tool called Bricks comes into play. I haven't really talked about this at all, so maybe I can open up here. And Bricks is really a super, super vast collection of pre-built modules for natural language processing. For example, you have many, many cool modules for classifying texts. For example, you can use these bricks to detect languages in a text, or to get a sentiment classifier into your project. You can also use these bricks to extract specific information from a text. So this can be really useful if you want to extract personal identifiable information like names or maybe locations and dates. And you can also use these bricks to transform your data. Maybe you want to translate them. Maybe you want to summarize long paragraphs into a shorter form. For that, you can use these fantastic brick modules. But you can also use them to, for example, filter out all the nouns that you have in a text. For this, we are again using the Spacey library that is running in Refinery under the hood. And using this noun splitter brick module, we can extract all the nouns that are in any given text. And we always provide the Refinery code that you could just, of course, copy paste into your project, or you can directly load in these brick modules via the dedicated Bricks integrator. And we also, of course, always provide a more, we call it regular code that you can just copy paste to use it in, for example, a standard Python notebook or a Python file. And on the right-hand side, you also have a small sandbox, a small playground, where you can always get a first feel of the brick module to really get a deeper understanding of what this module is actually doing and to find out if it's actually the right module that you want to use and that you need. So here, for example, we have a text stating my favorite noun is friend. We can just run it. and see, okay, the result is just a list of the nouns in that text. And so maybe your favorite noun is not friend, and you can say, okay, my favorite noun is, I don't know, table. You can run it again, and we can see that now the nouns table and noun is retrieved. Or we can say my favorite word is table and see that now table and word are retrieved. So you have this
all
interactive
these
playground.
bricks tools have an API?
Could you repeat that? I didn't quite get
There's
that.
a question. If all these bricks, these chunks, these components have an API that we can invoke.
So if you would like this, like to use this in a Python notebook, no, there's no API to freely use. What you can always do is just grab the code here, or if you are using Refinery, you have the option to directly search for a module in Bricks via the Bricks integrator, and then, for example, grab a brick module that you are interested in, and load it right into Refinery.
That's easy.
Mhm.
Yeah, so there is no API that anyone can use from, I don't know, their terminal, right?
At least
So
not for production use cases. I think there's of course an API that is meant to be used for the example inputs right here, but that's only really for testing out the brick modules, but nothing that you would actually deploy into a productive use case. That's actually where Refinery comes in. So Bricks is only really the repository you can think of all these components, but you can use Refinery to load in these components, and you can then use these components in Refinery. And in Refinery, you also have an API service that you can then deploy into a productive use case. Okay. And the great thing is that you can, with just a few clicks, can download or integrate all of these modular components from Bricks. And if they already satisfy your needs, that's fantastic. Then you can just run them. And we can see that actually, yeah, here we have a new attribute then that extracts all the nouns from the original paragraph. But maybe you also want to extract adjectives or other things with the code here. And then you always have, of course, the freedom to just programmatically change the code that was loaded in here. So you have a lot of freedom with all these modules that you can load in here. And you don't have to work with what's given to you, but you can use it as a basis to then build upon.
why would we actually want to extract nouns? Is it because like nouns carry some meaning, and this is probably what we ask about, right?
Yes. So what we want to do in a later step is we want to actually embed these individual nouns. And when you think about these RAG use cases, oftentimes we see that users write very short queries. And when we only embed the nouns, it can be quite, or it can be a little bit more easy to find similar results and data points for queries that are very, very short. And so we also want to extract the nouns to cover that part of queries.
Thank you.
Okay. So let's run that. Again, it only took a couple of seconds, and then the new attribute is also ready. The new attributes are hidden by default, but if we click on Do Not Hide and go back to the data browser, we can see now we have not only the original paragraph, but only individual sentences. And also we have extracted all the nouns, and we have stored them in dedicated lists, which we can use for the next step, which is going to be really, really important, which is the embeddings that we are going to create for these three attributes here. And these embeddings are really, really important when it comes to the similarity search that you do at a later stage of the RAG project. And when you have, for example, very short queries, you want to make sure that even for those shorter queries, you are able to actually find and retrieve relevant data points. And for creating embeddings in Kern AI Refinery, you have quite a lot of options. And you can use, of course, open source models from Hugging Face. We're going to take a look at that in a minute as well, of how you can maybe find the right open source embedding model for your project. But you can, of course, also use a service like the OpenAI embeddings or from Cohere or from Microsoft Azure, of course. Or you can use a very simple method from standard Python. If you're interested in just calculating TF, IDF vectors, you can also, of course, do that. And if you are maybe feeling a little bit lost when it comes to embedding and vectorizing your data, then I highly recommend you to check out the MTEB leaderboard on Hugging Face. Basically, maybe I can make it a little bit bigger. And the MTEB leaderboard, so the Massive Text Embedding Benchmark, is a collection of benchmarks for all kinds of embedding models and tasks for these models. So here you can basically take a look and click on the thing that you are interested in. In our case, we are interested in data retrieval and using these embedding models for retrieval. And then you can check out the leaderboard to get a first feeling of, okay, what models are out there and how well are they performing. And then you can also check out some individual models to learn more about them. And the cool thing about Hugging Face, of course, is also that you can see how many downloads it had and also how big these embedding models are. And one embedding model that I really, really like to use in many projects is, for example, the E5 models. So for example, the infloat E5 base V2 model is a fantastic model because it's very versatile. It's usable for many, many different RAG projects. And there's also a multilingual E5 model. So if you're dealing with a project in many different languages, or maybe your project is in a language where some English-only embedding models are not performing really well, then I can also highly recommend the multilingual E5 models. And what you can do now is simply grab a model that you would like to use. For example, I'm going to use now the E5 small V2 model because it's only 130 megabytes large. So even if you don't have a GPU or a powerful machine, you should be able to still use the small E5 model and get really, really good results, actually. So I'm just going to copy the name here, and I'm going to set the target attribute first for the content, so the full paragraph. Going to set all the filter attributes. This is important for the later steps if we want to query the vector database. And I'm going to repeat all of this for the other attributes that we also have just created. So for the individual sentences and also for the nouns that we have extracted. And you can see this is not running on a GPU, but on a normal CPU, I would say, and it's quite fast. Let me set the filters here as well.
So there is a question, why not use models with higher rating? Like we can just take the biggest one, right?
Yeah, of course, if you have the power or if you have the need, then you can just use a model with a higher rating or maybe even a managed service. For example, here the text embedding 3 small or the text embedding 3 is a model by OpenAI, which is new. But for example, let's take a look at the first models here. They are really, really big. So the highest rated model is a couple of gigabytes large. I think, yeah, this is over 10 gigabytes combined. And I would say for the project that we have, it would also be a little bit overkill. But yeah, of course, you can use a larger model as well if you have the hardware for it.
And what's the relationship between the tokenizer and the embedding model?
So actually, the embedding model only sees the text of the attributes that we have here. So for example,
Already tokenized text, right?
yes. What you can do is you can also generate what you can also do is generate token embeddings. So the tokenizer would then first split up the text that you have in smaller tokens, and then you can also embed these tokens individually. For example, if you want to do named entity extraction, if you want to extract really small parts of your text only, if there's like names that you are looking for. In our case, we are only interested in embedding the whole attribute itself, and there the tokenizer and the embedding model don't really have that much of a relationship.
So the way I understood it is we uploaded the file, right? And then for this file, for each column, we selected a tokenizer, or I think we selected tokenizer for the entire project, right? And then the tokenizer tokenized the document, the content, but when we put the content into an embedding model, it takes the entire attribute, the entire content of the column.
Yes,
So it's
exactly.
not text after tokenizing, it's before tokenizing. But because we have these computed attributes for which we used the output of the tokenizer, we used the spacey document. So this is an already tokenized document, and we put, because there was a sentence tokenizer that we used. So we kind of used the result of the tokenizer in order to build other embeddings on these computed attributes.
Yes, exactly. Yeah, that's exactly what's going on. So the spacey tokenizer is more of a tool that we can use to further transform the texts, for example, into these attributes here. And then correctly, as you said, these outputs of the tokenizer, we can then also embed. So what we just did is we embedded this, and then we also created an embedding function that individually embedded these sentences here. And then also for the noun attribute, it embedded the individual nouns that were extracted. All right. And all of the embeddings from the models are stored without the need to set up any databases or something in a vector database that we can query later on when we call the API. So we don't need to set up anything, and this is already ready to use and waiting for us to do some similarity search, which we're also going to do later on. But first of all, I would also like to talk about labeling tasks, because it's also yet another really powerful tool that you can use for data-centric RAG. If we take a closer look, maybe I can hide these attributes here because they can be quite long. If we take a look at our data, we can see that, for example, here we have a lot of documents that are either talking about like health insurance, or we also have some records that are talking about travel insurance. Sometimes they talk about both, or sometimes they talk about none of these topics. And so maybe if we have a customer that is writing a message to us, it would be good to, first of all, understand, okay, is the customer interested in a health insurance or travel insurance, or both, or none of these things? And here in Refinery, we have the power to very easily and very simply create a powerful classifier to do exactly that. And to build these classifiers, we first start off with a labeling task here. And in this case, we want to create a labeling task for the content attribute. And we can call it medical relevant, for example. If we want to find out, is the incoming message, is it relevant for medical insurances? And we can do the same for travel relevant. We can do the same for travel insurances. And in this case, we are interested in doing a multi-class classification. We can also do something like information extraction if, for example, the customer is writing down specific words about insurances and we want to retrieve these words, but for now, the classification models are fine. And then we can just set the labels, which are yes and no. Let's maybe give some different colors here. Let's take this nice pink, and lime green is looking good, and rose red, and maybe emerald. I think those are good colors. Cool. And now we have set up the labeling tasks, and there are now multiple approaches on how we can actually label our data to then train a small lightweight classification model. The most straightforward way to label the data is to go to the labeling page, which we have right here with a little label icon. And if we have only small amounts of data, we could, of course, manually label all of our data by hand, which is totally fine if it's not that much data. 110 records wouldn't take too long. Maybe it would take too long for this live session here. But what we can very easily do is go through all these records that we have and see, okay, is it really related to medical questions or travel insurances? And then label this by hand. For example, here we have a paragraph about medical treatment. So I would say, yeah, this looks relevant for medical questions, but not really for travel insurances, breach of obligations. Maybe let's do one or two more. Here we have a paragraph, quite a long paragraph about health insurance. So this is important for medical questions, but not for travel, and so on and so forth. What you can also do is you can jump into the heuristics page and create something that we call a labeling function. So a programmatic way to very easily and very efficiently label your data. So let's do exactly that labeling task. In this case, let's do it for the medical relevant labeling task. Create that. And what we can simply do is we can check, okay, if the word health, for example, is in our attribute, we just want to classify it as, yes, this is relevant for health insurances. So this is a very simple example of how one of these labeling functions could look like, but you can also, of course, use one of the many, many bricks that we have available to label your data. So what you can also do, for example, is load in a GPT model to label your data by a GPT model, where you can then just write down a prompt and say, hey, okay, I'm interested in classifying the relevancy for messages about health and travel insurances, and please output this if it is relevant for my task. Oops. Can also check out that brick module here. Yeah, and take this code and let GPT do the labeling work for you. But in this case, I think a very simple labeling function will do the trick and should only take a couple of seconds.
So I have a question. So this labeling should be applied to both the records we have in our database, but also later when the user asks something, we should also apply this to the user input. And in case we do this manually, like we will not really have the label during the runtime.
Yes, that's true. So what we basically do now is with the data that we already have, we label it and then use it to build a very small lightweight classifier so that this classifier can take over this labeling for newly incoming user questions, for example, if that makes sense.
And also there is a question from Juan, if you use any vector database for storing embeddings.
Yes, exactly. So for storing the embeddings of the embedding models, we use the vector database from Quadrant. So we have a quadrant vector database sitting in the background here of Kern AI Refinery, which we can, or which we use to store the embeddings and also do the similarity search later on.
I see why you need Docker. Oh.
Excuse me, what? Could you repeat that?
Now I understand now why you need Docker, because like a lot of things run in the background.
Yes, yes. And Quadrant is one of these things, but we have many different containers for the embedding services for models that are running. And yeah, that really makes it necessary to use Docker then. Cool. And you can see that just with these couple of lines of code, we were able to automatically label, I would say, a good chunk of our data set. And imagine if you have thousands of records in your data set. By using these labeling functions, you can really speed up the labeling process of your data. And with that, you could now also say, I'm ready to create a small classification model now. And if you want to do that, you can simply click on New Heuristics again and click on the Active Learning component. You can also use the Active Learning component to help you label your data if you want to label it more, but you can also directly implement it into a productive use case. And these active learning functions are fed with the embedding data that we have created previously. And they are often very simple models, like a logistic regression that is then also trained with the labels that we have created previously. If I would now run this and use this, it would probably not yield the best results because I don't have labeled too much of my data. But if I go, for example, into the project that I have prepared here, we could see that it actually is usable in a productive use case right now.
How could we
And
see you went quite quickly? Like,
oh,
did you?
sorry. Yeah. So basically what is happening here, we load in a logistic regression from sklearn, and this logistic regression is then trained on the embeddings that we have for our content and also with the labels that we have just created.
Mhm. And you saw the accuracy somewhere, right? Like
Um,
concluded that it's better, and like how did you make this conclusion?
So I'm not sure why, but it's not showing the accuracy here at the moment. But what we can do is we can actually try out this model via the API that we have for Refinery and see if it's working correctly. So as of right now, as of the end of February, we don't have the API service of Refinery open sourced yet. So you are not going to be able to see this field right here. Oops. But we are going to open source Gates, which is our API service, very, very soon. And so all of what I'm going to do next now is going to be relevant, going to be very relevant anyway.
So right now, as I understood, so you use the cloud, this app.kern.ai,
Mhm.
locally when we run Refinery start. It's almost the same, except a few things like the one we mentioned right now.
Yes, so the open source version should have everything that I showed up to this point. And in a very short time, we're also going to open source the API service that will allow you to locally set up the API service as well, and then use it together
So
with Refinery.
basically, it means that we can easily train a model, and then with one click, it gets deployed.
Yes, so let me show you this in a notebook that I have prepared, where we can see how this would look in action. Okay, so you should now be able to see my Visual Studio Code. And what I have here is a very simple snippet that is using requests, and that allows me to call the API, or that allows me to call the Refinery project that I have just created. we can also check out the page on how to basically start the API service. And we can see that here we have the medical classifier, which is already started up. And here we also can select the embeddings that we have previously created to use these for similarity search. And if I now run this and input a text that could come from a user, for example, like this one here, where the user is saying, okay, hey, I got sick and I can't take my flight. Is this covered by my insurance, by the Global Guard insurance? I could just send this out, and in just a very short amount of time, we then get the response from the Refinery project. And here we can see that this is the user question that was just asked. And we also have the transformations that we just created in Refinery right here. So the user question got split into individual sentences by the tokenizer that is running in Refinery. And also we were able to extract the nouns in the sentence. So for example, we could also use the noun not only to create a new embedding, but also maybe to do some keyword search in a different database. And what we can also see here is that the classifier that we have trained actually gave us a prediction that, hey, yeah, the text that just came in from this user is actually relevant for medical insurances. The confidence is not perfect. It's 67%. But yeah, when we keep in mind that we just set this up live, it's actually quite impressive, I would say.
And the way it works, it converts the content into an embedding and then runs logistic regression on top of the vector, right?
Yes, exactly. At least for the classifier, it is exactly that. And besides the transformations and the classifications for the incoming text, we also, of course, get similar records from our vector database. So here we can see the name of the embeddings that we have created previously. And here we have then also all the records that were found by the similarity search. And if you want to take this now to the next step, you can, of course, also train classifiers, for example, for the relevancy. So often what you see is that retrieved records are maybe somewhat similar in the way that the contents are, but they are not always very relevant. And by using this method that I just showed here in Refinery, you can also create your own custom classifiers to then classify the relevancy. And this is exactly what we are doing, for example, in our orchestration tool, which is Cognition. And so if there's no further questions about maybe the API service or gates, I would then jump over into our tool.
But I have concerns that like we should try to finish the main content.
Okay.
Yeah.
Okay, then let me quickly show you our platform Cognition for retrieval augmented generation. Oops. First need to log in here. So what I have here is I have basically the same
Cognition. So is it something we also, when we do Refinery start, we do not have Cognition, right? So this is something we need to run separately.
Yes. So the tools that we have open sourced at the moment is our Refinery and also Bricks, and later on our API service as well. But Cognition is our platform that we have monetized at the moment. And so this is like an orchestration layer on top that you cannot use if you just download Refinery at the moment.
And the way we access Cognition is like how exactly?
So at the moment, Cognition is only a managed service, and you would access Cognition via cognition.kernel.ai. And the background, in the background of Cognition, we still have running Refinery still. So Refinery is always in all the projects that we use, kind of the data management platform that we deploy. And if you say, okay, I have a really, really complex rank use case and I want to take everything to the next level, that's there then when you can use Cognition to really get started with that. Okay, what I did here is I used the data that we have, so the insurance documents, and I have created a Cognition project on top of these documents as well, which is basically the same as I showed you before. So if we check this out here, this is also a Refinery project in the background, which contains embeddings and labeling tasks. And what we do here in Cognition is we get a much more detailed and much more improved way of building up individual strategies for our retrieval augmented generation. And what I can do here as well is, again, ask a question like, for example, I got sick and I can't make my flight. Is that covered by my policy? So a very standard RAG question, I would say. And we can check the answer here from the large language model. And the big upside of Cognition is that you have very detailed insights about all the steps that your data is flowing through and about the steps that are happening to, for example, retrieve and filter out data. And here, for example, we have a question enrichment component, which classifies the incoming questions by their communication style or the question type or by their complexity, for example. And all of this in the back end is powered by Refinery. So this is really at the heart of all of our projects, and which allow you to really set up these really detailed and fine-grained RAG projects. And here in Cognition, we could then also, of course, do some data retrieval. Again, these embeddings here are stored in the vector database in Refinery. And we could then do some further processing of the retrieved results, maybe re-rank them either with a service, a managed service, or with a model that we have trained ourselves in Refinery, and then push the result into a language model that we have right here. Just to give you the intuition of why and how we use this orchestration layer that we have in Cognition on top. Right.
We kind of jumped a bit too quick for me from Refinery to Cognition. So I was maybe I missed something. Like Refinery alone, what we did in Refinery is not enough to build a chatbot, right? Or it's enough?
It is already enough to build a RAG project. So what I showed you here in my notebook, for example, this is only using Refinery. And here we already have the vector database, some data transformation techniques that we can use. But it is a very simplified version of a RAG project. And
what here in results, we got similar documents, right? So it's not yet, so we did the retrieval part, but ANG, augmentation and generation are still up to us, right? So we get the results, we built our prompt, we send it to a language model, right? Then the language model processes it and gives us back the answer, right? So the Refinery takes care of the R part here in the 3 letters.
Exactly. So we could now extract the similar records and all the metadata that we have created, and then feed this into a language model. Maybe here in the next cell, we could then do an API call for a language model or something similar. But Refinery itself does not offer you the ability to push everything directly into a language model and build up the whole project. It just takes care of the data management and the very difficult part of enriching your data and taking care of the data.
You happen to have a notebook that shows how to do this?
Um, I'm not sure. Maybe also I can share something like this after the
Yeah,
session
it would be
if you would
quite
like.
useful. It's like we already have the R part, which is probably the most difficult one.
Hmm.
And then now we just need to build the prompt and send it to a language model. And
Hmm.
it's probably will fit a notebook, right? So like if
Yes,
we have like that.
exactly.
And then
Exactly.
we can do this in a notebook in Visual Studio Code or whatever. But what's the name? The Cognition, right? So what the
Mhm.
Cognition tool gives us is that instead of coding it ourselves, we have this low-like interface where
Mhm.
we can define all the steps and say, okay, like here's our retrieve records. I can see here retrieval step, and then you add re-ranking here, and then augmentation, right?
Yes,
And
exactly. So here we have the possibility to directly get the data from Refinery and get the similar records and all the data enrichment, and then push this into a language model. For example, here in this case, I just use a simple GPT 3.5 Turbo, but you can also use open source models if you want to, and then take the data that you have retrieved and put it into the language model. And the really nice thing about Cognition is that you have the possibility to add all the customizability or all the customized steps that you need to actually make sure that the right data is found um, and that you apply the transformations that you need um, along the way.
can we see the prompt that you use?
It's a very simple prompt. So here I just said, you're an AI assistant for the Global Guard Insurance Company, and your job is to answer questions about these policies, be friendly and helpful, answer with a maximum of 4 sentences. And then here, so we have the system prompt, and then further down below, we have the user prompt, where we use something called Mustard.js, so a special framework to then inject the similar results and the found context into the prompt of the language model. So here we
Yeah.
have we have the retrieval results. We can also check this here. So this is the really nice part about all of this. We can check the output of all these nodes. So here we have, for example, the retrieval component, and we can check all the retrieved results here, which are quite a lot. So all of these are records from our database that were found. And here in the next step, we re-rank them a little bit and filter out irrelevant records. And if we check this node here, then we can see, okay, it's much fewer records that are still left, which we can then put into the augmented generation part.
And I already see questions about cognition. So first of all, like, is there any like free trials, or maybe it's free for individuals? Like, what's the pricing?
So we always say that the first document is on us. So if you are interested in trying this out, then feel free to contact us, and then we can always prepare a demo use case for you where we show this on your own company data. And apart from that, I don't have the concrete pricing in mind, but yeah, definitely feel free to reach out if you would like to have more details on that.
I see. Um, do you have a website where you have training documents and videos?
Yeah, we have a really nice YouTube channel, Kern AI, which you can check out if you are interested in learning more about this. So you can see my face popping up quite a lot here on the YouTube channel. And here we also tell a little bit um, about Refinery and Cognition. And you can also check out our documentation, of course, which is quite thorough, especially for our open source tools, where you can read up on all these things that I just showed you about creating embeddings, labeling tasks, and all these things.
Okay. So I'm just, do you want to talk about anything else? Because there are other questions and I'm not sure if we should talk about that.
From
Maybe
my
there's,
side, I think that would be it. Maybe again, if you would like to stay informed when we, for example, open source our API component or when we release our data-centric RAG guide, then feel free to sign up to our newsletter. Other than that, I'm ready. Oh, I'm done from my end.
okay. So a few question, like a question from Serdar, if the model can do tagging. And the way I understand this question is we have multi-class classification and we have multi-label classification, right? So we saw an example of multi-class classification when at the end we have only one result. Like for each record, only one class is possible, right? But tagging is more like it can be, I don't know, health, travel, and so on, like a list of labels, right? Can it do multi label classification, or we do it by creating multiple classifiers with yes, no labels?
So if we want to classify the whole text, yes, then we would need to create multiple labeling tasks. So for example, here we want to find out if one text is for traveling or for health insurance or maybe for both. And what we can is then simply create two labeling tasks. But we could also create, for example, information extraction tasks if we are interested in finding specific words, for example, in a text.
And why would we do that? Why would we?
Okay. Yeah, of course. For example, if we want to find out names or locations that are hidden inside the text. Maybe the customer is writing his customer ID inside the message, and maybe we want to retrieve only the customer ID to then put this into a different database to retrieve some more information about the customer and things like that. And for the information extraction, we also offer quite a lot of really cool bricks that we can use then.
Okay. So I saw their BAC, credit card extraction. Okay. Like basically, like if somebody accidentally put their credit card number, which they're not supposed to do, but if they did that with a chatbot, you can detect that and mask it out, right?
Yes, exactly. Yeah, that's, for example, another use case. In some cases, you are required legally to remove some personal information from incoming messages. And with these information extraction modules, you can then find out the position of, for example, a credit card number or an email, and then remove this part here so that you don't need to remove any information manually.
And there is a question also about max confidence, mean confidence, sorry. So mean confidence was set to 0.7. Can you please explain what is that? So I guess this is the output of the classifier, right? So the classifier says the probability that this document is about health is 0.7, right?
Yes, so that's the threshold of when the classifier will set a label. So when we query it via the API, we will always see the result here. And so here it's actually below the threshold, which is okay. We just want to use this then in, for example, the rank use case. But this threshold here is really relevant if we want to use these active learners to label our data. And so that's why we can set the min confidence value here as well.
And then there is a question what picks do you recommend to increase the confidence? So I think the question is like the confidence here is the probability that this document belongs to this specific case, right? So maybe you don't really want to increase that, right?
Yes, exactly. So the best way to just increase the confidence of the model is to just provide it with more labeled data basically, and then retrain it. And the model here is called an active learner because what you usually do is you train a small amount of your data set. So in this case, for example, 20 records or 25 records. Then you train the first version of the model and take a look, okay, is it working as intended? And if not, you label maybe even more data, maybe half of the data set, and iteratively try to figure out the best approach to label all of this.
Well, I see while we were talking, we got a few more questions.
Mm-hmm.
From Michael. Can you give advice about cases that require automatic generation of human readable reports? For example, auditing a set of documents or logs. So I guess here the question is not about like using this as a chatbot, but more like, okay, here's some data, give us some report on the data.
Yeah, of course. I mean, the chatbot is only really the first logical implementation of a RAG use case, but you can also use RAG for many other different things. So we, for example, use RAG a lot of the times for document comparison. So if you need to have a structured comparison of the contents of these documents, you can automate this also quite nicely. So what's important in these automated processes when you want to generate, for example, new texts? Make sure that the search is going well, and you want to really avoid that there's irrelevant context going into your models. And with these projects, you also have the freedom to not be really quick with the response. So if there's like a chatbot, you want to have a very quick response. But if you automatically create, for example, summaries or reports, you most likely can wait for a couple of seconds to generate the report. And you should use that time that you have to maybe implement another re-ranking model or a cross-encoding model to filter out irrelevant results from your information retrieval.
We have a couple of more minutes. We have more questions.
Mm-hmm.
Okay. So questions from Jessica. Hi, Jessica. She's asking, how can we contribute to the project? And do you have any tips to get started?
Mm-hmm. If you would like to contribute, the best way would probably to go to the GitHub repository of Bricks, which you can find on code-kernel.ai/bricks. And here we have very detailed guidelines on how to contribute, for example, one of these NLP components that you can then see. And we also have already a list with ideas for new brick modules, which are either waiting for some improvement or which are not implemented at the moment, which you can just take up and build your own brick module out of this and then contribute relatively easy. And also, of course, feel free to leave a star for bricks as well.
Mm-hmm. Okay, and so when it comes to Refinery, so Bricks is something like it's a library for these recipes that are copy pastable, right?
Exactly, that's right.
Probably also possible to contribute to Refinery itself, right?
You could also contribute to Refinery. If we check this out, there are probably some open issues here as well. I would say, yeah, maybe go to the issues page of Refinery, take a look at the issues that are open, and if you see something that you are interested in working on or improving, then feel free to first of all reach out to us, and then we can also, of course, help you to get started contributing to Refinery.
Mm-hmm. Another question is if I want to use it for business on scale, can I work in the cloud? So I'm not sure if the question is about your cloud offering, like this we saw app.kern.ai, or the question is of setting up Kern in, let's say, my own AWS or
Yes.
GCP Azure environment. But maybe you can answer both.
Yes, so both is definitely possible. We have a managed service that we host, basically, that you can use. But if you already have your own cloud provider that you can only use in a business context, for example, Azure or AWS, or maybe even a server that is on-premise, we are very happy to deploy our tools to a different cloud provider for you as well, or even on-premise services.
And if somebody needs that, they should reach out to you via Discord, right?
Yeah, you can reach out via Discord, or you can just reach out to me via LinkedIn if you'd like, or you can go to kern.ai and simply click on book a demo, and then someone from our team will reach out to you.
Ah, you have a list of use cases. Insurance
Yes,
policy.
we have a quite extensive list of use cases. So what we've talked about today is like AI assistants in RAG and insurance industry, but there are many, many, many cool use cases that you can apply this to.
Maybe one more question, and then
Mhm.
one goes home and enjoys dinner. Uh, or those who just started, yeah, you'll have to work. Anyways, can you do RAG with tabular data? Like we saw an example with unstructured data, with text, but let's say we have, I don't know, like this Titanic data set, right? Where we
Mm.
have numbers and categorical variables. Can we do RAG on that?
Yes, but what is possible is that if you have a PDF document where you have also tables in them, and maybe the tables have nicely named columns, it is possible to use these tables quite well actually in a RAG use case. So maybe, for example, you want to retrieve a pricing list from a PDF document, which is also then called price list. That works quite well. What doesn't really work well if you only have numbers. For example, yeah, you mentioned the Titanic data set. Maybe with a little bit of tweaking, it could work, but it would be a little bit more difficult.
But I
And
guess we need to understand why do we want to do that? Like what kind of questions do we want to have answers to, right?
yeah, maybe if we think about the Titanic use case, maybe you want to have like a chatbot where we say, yeah, how many people survived, or I don't know.
It's like more like doing analytics for us.
Hmm.
Interesting.
Yeah,
I
maybe
think
for an analytics use case.
more
But
like
then,
RAG, but more like agent kind of work.
yeah, for that use case, that could also work, but it would require you to transform the data maybe a little bit. Yeah.
Like pre-compute all these possible analytical questions, right?
Yes, definitely. Or maybe chunk the data into smaller bits and then push this into a GPT model and give basically the instruction like, hey, here's this small part of my tabular data set. Please generate me some description text for this. And then we could use that to retrieve it in a RAG use case. So maybe something like this could
Yes,
work.
if you start with an end in mind, like exactly how we want to use, then it's kind of clear, and then we can work backwards from
Hmm,
that.
exactly. Yeah.
I guess that's all. Yeah, thanks for staying with us a bit longer for 5 minutes. We
Mhm.
appreciate it. And thanks everyone for joining in today, asking questions. And Leo, when you have time to, uh, please share the slides with us. And when you have
Mhm.
time to implement a simple notebook that shows how to do a simple rack application,
Of
uh,
course.
would be awesome. If you can send us the link, then I will put this in the description.
Will do. Of course.
Okay, then thanks everyone. Thanks, Leo. And let's enjoy the rest of our